Okay, so basically we're working on a couple of the topics we've been doing for the last couple of days. So the first part here is finding coterminal angles, one positive one and one negative one for each angle given. So say on the first part, since it's in degrees, we're going to add or subtract 360 degrees. Okay, so I'm going to start by taking 150 degrees and subtracting 360 degrees. When you take 450 degrees, subtract 360 degrees, you get 90 degrees. Well, there's one positive one. Now I'm going to take 90 degrees and subtract 360 degrees again. And when you do that, you get negative 270 degrees. So there's my positive one and there's my negative one. Now I knew to start by subtracting 450 degrees. If I had started and added 450 plus 360, I would have found a coterminal angle, but that would have been a positive one. When I subtracted 360, I would have ended up with positive 90. That's still not a negative one. So I knew since my original angle was greater than 360, I was going to have to subtract more than one time. So getting to my negative one, I would find my positive one at the same time. Okay? So let's look at the next one. I have a radian measure. So to find coterminal angles, I add or subtract 2 pi. So I'm going to start by taking negative 9 pi over 2 and adding 2 pi. Well, that's the same thing. So we have to get common denominators. I'm adding 4 pi over 2. So negative 9 pi plus 4 pi is negative 5 pi over 2. Well, that's still a negative one. So I did find a negative coterminal angle, but now I need to find a positive one. So I'm going to start at negative 5 pi over 2, and I'm going to add it again. So when I add negative 5 pi over 2 plus 4 pi over 2, I get negative pi over 2. Well, I still haven't gotten a positive one, so I got to do it again. So I take negative pi over 2 and add 4 pi over 2, and I get 3 pi over 2. So finally, I get my positive coterminal. And of course, I could use either one of these as my negative. Both of them are coterminal. So sometimes you got to do it more than a couple times. Okay? But you've got to keep going until you get at least one positive one and one negative one. Okay? And sometimes it just needs multiple times. All right. So we've done this before. This is drawing your reference angle. Okay? So we've done it with degrees, but now we're going to do it with radians. So you have to remember 0 degrees is the same thing as 0 radians, and 360 degrees is the same as 2 pi. 90 degrees is pi over 2, 180 degrees is pi, and 270 is 3 pi over 2. Okay? So 5 pi over 4, since we're going to draw it, which quadrant are we going to end up in? Well, 5 pi over 4, is that bigger or smaller than 1 pi? So are we past 180 degrees? Well, 5 pi over 4 is definitely bigger than 1 pi. So it puts us in this quadrant right here. So this is my angle. This is 5 pi over 4. Now, my reference angle that I'm trying to find is this angle right here, this distance from my angle to my x-axis. And we normally say that's theta prime. So how far away is this angle 5 pi over 4 to pi? Well, pi is the same thing as 4 pi over 4. So how much farther do I go to get from 4 pi over 4 to 5 pi over 4? Well, this is pi over 4. So my reference angle is pi over 4. And again, we're doing the same thing we did with degrees, but we're just doing it this time with radians. Okay. So next we're going to practice converting angles from either degrees to radians or radians to degrees. So convert the angle either to degrees or radians. So the first part, I'm in degrees. So I need to change it to radians. So to change it to radians, I multiply by pi over 180 degrees. Degrees divides out with degrees. So I get negative 330 pi over 180. Both are divisible by 10. And then both are also divisible by 3. So negative 33 divided by 3 is negative 11. 18 divided by 3 is 6. So negative 330 degrees is the same thing as negative 11 pi over 6. Now we're going to do the same thing with 5 pi over 6, but we're going to change it to degrees. So we're going to use the same ratio, but reversed. So this time I'm going to multiply by 180 over pi. And this time pi divides out with pi. So we left with 5 times 180 degrees over 6. Now, 18 is divisible by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. So basically, we end up with 5 times 30 degrees. And 5 times 30 degrees is 150 degrees. So 5 pi over 6 is the same thing as 150 degrees. Okay? Easy. Hardest part about that is just reducing the fractions. All right, the last part. Find the arc length and area of the sector for the following central angle and radius. So they've given us a radius of 5 centimeters and given us theta as 135 degrees. So often what I like to do is draw a picture, okay, of what we're dealing with. So we have a central angle, which means we have a circle. Our angle, this right here, is 135 degrees. Okay? So this right here, from here to here, this is the arc length we're looking for. And we're also going to find this area. Okay? And that's when my radius r equals 5 centimeters. So before we can get started, now we know arc length is s equals theta r. Well, remember, theta has to be in radians. So I'm going to come over here and find theta, which is 135 degrees. To change it into radians, we multiply by pi over 180 degrees. So degrees divides out with degrees, so we get 135 pi over 180. Both are divisible by 5, and even more so divisible by 45, and we get 3 pi over 4 when we reduce. So theta is 3 pi over 4. So this is 3 pi over 4. So now that we know that, we just plug in. So 3 pi over 4 times 5 centimeters. That means this is 15 pi over 4 centimeters. So 15 pi over 4 centimeters. That's my answer. And then we're finding area. So area of a sector is 1/2 theta r squared. So this is 1/2. Theta is 3 pi over 4 times 25 centimeters squared. So put this over 1. So 3 times 25 is 75 pi. 2 times 4 times 1 is 8. So that is my answer. 75 pi over 8 centimeters squared. Okay, so the hardest part of this problem is A, remembering the equations, but B, making sure that we convert our radians, or sorry, our degrees to radians.